Hello everyone, welcome back. Today I'm going to explain a problem on flexural strength. A symmetrical double T section has flange width of 1200 mm and 140 mm thick. The overall depth of beam is 1700 mm and thickness of each rib is 150 mm. The member is pre-stressed with an effective pre-stress force of 7500 kN through the cable located at a distance of 150 mm from the soffit. The characteristic strength of concrete is 40 Newton per mm square. Assuming that grouting is 100% effective, determine the ultimate moment of resistance of the section, adopt IS provisions. First of all, here diagram is not given. So according to the given data, we should write it. It's a T section, symmetrical double T section. So you should write two T sections which is symmetrical and complete width of the flanges 1200 mm and thickness of the flanges D, it is represented as capital DF equal to 140 mm and overall depth of the beam is 1700 mm and thickness of each web or rib both are same. It is denoted by BW equal to 150 mm here, 150 mm here. The member is pre-stressed with an effective pre-stressing force of 7500 kilonewton through the cable located at a distance of 150 mm from the soffit. That means here cable is present. It is present at a distance of 150 mm. So it should be measured from the bottom to the center of the cable. Remember, it's from the bottom to the center of the cable. Soffit means bottom to the cable is 150 mm and characteristic is given and grouting is 100% effective. So using this information we should calculate ultimate moment of resistance of the section. So let's start with the solution. See here they have given P equal to 7500 kilonewton, FCK characteristic strength of the concrete 40 Newton per mm square and they had not mentioned anything about characteristic strength of the cable. So I'm just assuming FP has 1600 Newton per mm square. So after assumption we should find out how much is the area of the cable. It is not given, so with these help we can find out. That is, generally we know that stress is equal to force by area of cable. Stress is 1600 equal to force, it is in kilonewton, convert that it into Newton. So 7500 into 10 power 3 by AP, area of the cable, we will get 4687.5 mm as a area of the cable. Next thing is, see here, we one thing is first you can check whether the neutral axis is within the flange or not. If you are confident enough that neutral axis won't be in the flange, it will be in the web, so you can go for a direct assumption that assume neutral axis lies within the web, or else you can check assume neutral axis lies within the flange, that is XU is less than DF, like that you can assume it. But here I have not done that, directly I have gone for assume neutral axis lies within the web. I don't think it is lying in the flange, so I went for assume neutral axis lies within the web. If neutral axis is in the web, it will be more than depth of the flange. So it is XU is greater than DF. And we know that a generalized formula for calculating the area of the flange, area of the cable for the web, area of the cable for the flange is by taking area of the cable. So formula is AP equal to APF plus APW is equal to 4687.5 mm square. We have already know how much is AP, so just equate it to that value. Next, APF. Here, the formula for APF, that is area of the area of cable for the flange, is 0.45 into FCK into BF minus BW into DF by FP. But here the important thing is it's about BW. Here you just go back to the diagram. What is the width of the web or rib? It is 150 mm. But here I have considered it as 300. That means I am considering width of both the web or width of both the rib. So don't forget that it should be 150 plus 150 while taking BW. And BF is a complete width of the flange. It is 1200 into depth of the flange by FP value, that is 1600. After calculation we will get APF has 1417.5 mm square. This is area of the cable for the flange. Now we know area of the cable for the whole section. In that we know only particularly for the flange this much should be taken. So using these two values we can find out how much is the area of the cable in the web. So APW is 4687.5 minus 1417.5. We will get APW as 3270 mm square as a area of the cable for the web. The next thing is modified ratio. Why do we use this modified ratio? First of all, the ratio is formula is AP into FP into B into D into FCK. This is a standard formula. But why did we use this modified one is we are assuming that is modified as APW into FP by BW into D into FCK. Remember why did we take this APW and BW is we have directly assumed that neutral axis is lying within the web. So because of that purpose we have written APW and BW. If neutral axis was lying in the flange itself, then there was no need to do any modification. Directly we should use this formula. So after modification, APW is known, substituted into 1600 divided by BW. BW value is 150 plus 150 is 300 and remaining value should be substituted. So we will get a ratio as 0.28. Now using this ratio, that is 0.28, in the table we should check what is the depth of the neutral axis, that is how XU value should be found out. So XU by D can be found out from the table by using this ratio. So let's go and check the table. Okay, here whatever value we have got, it is for this first column, it is 0.28. The ratio is this one, value is 0.28. Do we get any value of 0.28 here? No, but it is present somewhere between these two values. That is, 0.28 is lies between 0.25 and zero point 0.3. That is for the first column. And next is XU by D ratio column. I should check for column 4 or check for column 5. We should decide. How do we decide whether it's a pre-tensioning or post-tensioning? Go back to the question. You will get the idea. See here, in the question itself, they have given assuming that grouting is 100% effective. Always this grouting or duct is filled with the cement, that concept will come for a post tensioning. So indirectly they not indirectly, directly they have given that it's a post tensioning with effective bond. So because of that reason we should refer the fifth column. For 0.25 the value is 0.488. For 0.3 the value is 0.558. This is the value. Now we required what is the value of 0.28 in this column. So interpolate, we will get the answer. Whatever I had shown in the table, I have just typed here, nothing else. 0.28 is how much is? It is 0.53. After interpolation, we will get 0.53. We know how much is the effective depth. So, XU is 821.5 mm, which is greater than the DF. Go and check. The DF itself is 140. So, for that, it is greater than 140. So, it is obviously, it is not lying in the flange, it is lying in the web. Neutral axis is lying in the web. Next is okay. Here we should write a statement. Hence, assumption is correct. Whatever we have assumed. Okay, let me show you what was the assumption. We have assumed that neutral axis lies in the web and XU is greater than DF. That was our assumption. So we have got that assumption right. XU is greater than DF. So just write a statement. Hence assumption is correct. Now after the after XU calculation and all, we should find out what is the how much is the ratio of this. Using this ratio value, we should find out how much is FPU. FPU is nothing but ultimate tensile stress in the tendon. So to find that, again we should go back and refer to the column. So how to refer? First, what is the value we have got? That is, the ratio is 0.28. For 0.28, again 0.28 is not here, and we need a value for this ratio. Okay, so if we need value for this ratio, either we should go for a second column or third column. But here it's not a pre-tensioning, directly it has been given that it's a post-tensioning with effective bond. So I should refer the first column as well as a third column. So 0.28 lies between these two values, that is 0.25 and 0.3, and take the corresponding values of this. It is for 0.25 it is 0.90, for 0.3 it is 0.85. The value is in between those two. So go there, see the note here. I have just written all the values here. So if we extrapolate these values, we'll get the ratio as 0.87. So we know how much is Fp, substitute multiply it, we will get Fpu as 1211 Newton per mm square. The final stage is moment of resistance. Always remember, for a if the neutral axis is present within the web or in the web, the formula of moment of resistance is this one. So mr or mu, you can denote however you want, equal to fpw into apw into d minus 0.42 xu plus fp into apf into d minus df by 2. So this is a formula, moment of resistance formula for the neutral axis in the web. Afterwards, substitute all the values and we will get mr has 8128.3 kilonewton meter as a value. Okay, so this is how the calculation is done when the neutral axis is lying in the web. Hope you are clear with the table values and all. The most important thing is how to refer to this table. If we are thorough with referring the table or identify which column we should refer, then this problem is very easy. There is no such a difficult thing in this. And the important part is, always remember, we have a two table, that is table 12 and table 11. For when we refer to the table 11 is when it is having a effective bond and with a rectangular section. For that we will refer this table 11. Okay, so keep that in mind. We can solve easily. Hope you have understood. Thank you.